Let us discuss today what is prompt engineering, why prompt engineering is required for large language models, what are the different types of prompt engineering, why different types of prompt engineering might solve different tasks in the large language models. So there is a legacy paradigm, which means you ask a simple query to large language model, it would able to produce an answer. Sometimes this simple query might not give a desired output. It may not coherent with your query because large language may not understand many more contextual information around your query, so that it cannot able to provide the right answer for your. So this becomes an engineering process where you can define a system structured instructions for your prompt, so that you can enable the cognitive path of the large language model to get the desired results. So in order to enable the cognitive paths of a large language model, your prompt should have a structured instructions where you can define a role and logical steps and systematic instructions. Then you can form a context vector in the form of few examples, or in the form of data, or in the form of knowledge graph that support your structured instructions. And then you can also design a reasoning engines within the prompt, so that it will break the complex prompt into a sub prompts, and it solves each sub prompt and evaluate the sub prompt as a self critic and pass on the result to the next sub prompt, so that you will also design a logical reasoning there. This will enable to answer a lot of the mathematical or reasoning related tasks. And you can also have a external tools that will help to take an action from an output of a large language model. Please subscribe, like, and comment for more technical videos. Let us discuss the five pillars of prompting. The basic one is called the core prompting, where you ask a query without any example, or with one example, or with a few examples, which is called few shot learning. Whatever the examples are called the context, and the query will be answered with the support of this context. And the second type of prompting here is called reasoning prompting, which usually applies for the complex mathematical or reasoning problems. What it does is that it initially divides the complex prompt into a simple sub prompts, and these simple sub prompts are represented in a form of a chain of thoughts, or a tree of thoughts, or a graph of thoughts. And this process enables to improve the accuracy of the complex task. There is other type of prompting called instruction prompting. In this instruction prompting, you assign a role of a prompt, which is called as expert persona for that query that you are going to ask. Then LLM would able to understand your query in a better way. There is another type of prompting called multimodal prompting, which means you provide a prompt that would able to answer in the form of a logical text, or it can also provide an image, or it can also provide a video. There is a last type of prompting called a composition prompting, which is a kind of agentic framework where the prompts are designed in the form of chains, and each prompt might have a meta information to support what task it has to perform. And you are all connecting these chain of prompts in the form of a graph, or in the form of a tree. That will be the workflow of the agents. Let us discuss the context spectrum based prompting techniques. There are four types of context spectrum based prompting techniques. The first one is zero shot prompting, which means there is no examples to support your prompt, and the LLM output may be general sometimes, which may not coherent with your prompt. In the second type of prompting is called one shot prompting, where you provide one example to support your prompt, and the LLM can understand the context better and provide a better output compared to zero shot prompting. There is also a few shot prompting, which means you provide a few examples to support your context, and LLM can understand the context better with the few examples, and would able to produce a output which is more coherent with your query. There is also called role hybrid prompting. In this prompt, you will be able to define a persona and a structural example to enforce your domain expertise and output format. Then the LLM would produce a domain specific queries, the output that enhances the domain specific queries very well. Let us discuss the prompt engineering used in the reasoning and its evaluation. There are three types of prompt engineering used in the reasoning. One is chain of thought, second is tree of thought, third is graph of thought. These three types of prompt engineering used to solve different types of problems. The chain of thought is used to calculate the mathematical calculations, where the mathematical calculations is depending on the sequential step by step logic. So you can design one prompt for each logic, and you can connect those logics in a linear form so that it will perform the mathematical calculation. There are some kind of problems that depends on the breadth first search based or depth first search based tree prompting, where prompts are designed in the form of a tree, and you evaluate each prompt at a particular node and identify whether it is the best results. If that is not the best results, trace back to its parent and find the alternate path that leads to the best results. This is called tree of thought. This has high cost in calculation and also exponential execution, whereas the linear thought process is low cost and linear execution. There is a third type of prompt engineering called graph of thought, in which the prompts are connected in the form of a graph, and there are multiple edges connecting between multiple nodes in the graph. So the dynamic way you can interplay the prompt engineering here, and also it is non-linear in nature. It has a human creativity and detective leaps, and it has a moderate cost. It depends on the network execution. Let us dive deep into a graph of thought prompt engineering. This graph of thought prompt engineering basically useful for a non-linear representation of analogical terms such as earthquake and ground shake. If you use the chain of thought process, it cannot answer the meaning of earthquake and ground shake will be the same. So if you use the non-linear fashion in the form of a graph of thought, then this will understand those two phrases has the same meaning, and that improves the data insights by 5% when you apply graph of thought process for the T5 large language models. Let us discuss a graph of thought engine here. A graph of thought engine is a prompt engineering process that performs on a collection of prompts, where each prompt represents a sentence in the form of triple, where a triple contains subject, verb, object relationship. An edge of verb exists between subject and object. And if you can represent all the prompts in the form of triples, then you can perform the co-reference resolution or entity resolution by grouping all the mentions of the same entity in a cluster. Then you can represent each cluster with one representative entity or a node. Then it will perform all the prompts in the form of a graph of thoughts. Once you have this graph of thought in a dense noise free representation, then you can apply a graph of thought prompt engineering to detect analogies for LLMs to get your output. With this, we can conclude the first part of the prompt engineering, where we have discussed the five pillars of the prompt engineering, and we also have discussed the context enabled prompt engineering, and we have also discussed reasoning enabled prompt engineering. We have dived deep into a graph of thought engine and with an example on how to construct a graph of thought engine. In the next part, we will discuss how we would perform the prompt engineering for multimedia large language models.